4th day of this Leetcode challenge. So for those of you who don't know, this Leetcode challenge was started in the month of April, and every day they are going to upload one question. Today is the 4th day that we are solving this question, and today's question is move zeros. So let's read through the problem. Given an array of nums, write a function to move all zeros to the end of it while maintaining the relative order of non-zero elements. So we are given an integer array, and we have to move all of its zeros to the extreme right. Now this seems like an easy question, but there are some additional conditions associated with it. You must do this in place without making a copy of the array. So you are not allowed to make a copy of the array. And if you look at the method that they have provided, uh, it does not have any return type. So you cannot create a new array and submit it. What you can do is change the values of nums, but that is not allowed. So without making a copy of the array. The other condition that is imposed is minimum total number of operations. So obviously we can guess that there will be a set of swaps involved if we have to do this in place. So we have to do it with the minimum number of swaps. We are also given some hints here. So I'm going to open this hint because there does not seem any additional penalty associated with it. So this just seems to define what in place means. In place means we should not be allocating any space for extra array, but we are allowed to modify the existing array. So we can modify the existing array, but like I said, you cannot make a copy and then update the existing array. That is not called in place. However, as a first step, try coming up with a solution that makes use of additional space. So I'm going to give you an easy approach without using an additional array. Let's see what the second hint says. Okay, they are saying a two-pointer approach could be helpful here. The idea would be to have one pointer for iterating the array and then the pointer that works on non-zero element of the array. This seems interesting. It seems we can do this using the two-pointer approach. So I'm going to use this approach to solve the problem. So what I'm going to do is I'm going to create two pointers, start and end, and the invariant here would be that all the elements between start and end, including start and end, will be all zeros, and I'll be moving the entire set of zeros to extreme right. So one approach, the easier approach, which is in place and uh, which does not fulfill this criteria of total number of minimizing the total number of minimum operations, that would be like using insertion sort. So what you can do in insertion sort is let's consider this input. So it has 0. uh, so as long as for every non-zero number, what we'll do is we'll keep swapping it with the element on the right, the 0 on the right, not all the elements. If there is a 0 on the right, then we'll keep swapping it as long as we don't find a not as long as we find a non-zero element. So let's say I start off with 0. 0 is 0, so we'll skip it. So then we look at 1. One's left side has a 0, so what we'll do is swap 1 with 0, so we'll get 1 0. Now we move on to the other part which contains 0, so again we'll skip it. Now we come across a non-zero number 3, so what we'll do is our array contains 1 0 0 and 3, so I'll keep swapping 3 with zeros as long as I reach a non-zero number which is 1. So as long as my array becomes 1 3 0 0 in that case. Now only 12 is left, and I'll keep swapping 12 with its left side zeros, and we'll arrive at the result. So that would be something similar to what insertion sort does. I'll be using the two pointer approach, and what I'll do is like I mentioned earlier, so all the elements that are present from start to end will contain all the zeros, and I'll keep incrementing the end pointer and check if the data at end index, if that is equal to 0, then I'll my container size from start to end will increase. But if the element is non-zero, then I'll just swap it with whatever element is present at the start. So I'll, I'll explain while I'm writing the code. So I'm going to start two pointers, start and end. So all the elements that from start to end will contain all the elements that are equal to 0. So my invariant here would be that I've reached the end of the array. So if I reach the end of the array, that means all the elements from start to end are all zeros, and my work is done. So now what I'll do is I'll check if the element at the end index, if that is equal to 0, then that just means my container size can be increased. So I'll increment the end pointer. That means my container size of start to end has increased. The other possibility is the element at end is not equal to 0. So in that case, what I'll want to do is swap the element uh, at the end index with the element at the start index, and I'll increase the end pointer and the start pointer. Okay, since this can also be written as plus plus here. Okay, and I'll just write a swap function which contains which takes an integer array and two indexes and just a normal swap function. And now I'll override the ith index with whatever is present at j, and j can be overridden with whatever is in temp. So yeah, this seems to be fine, and we are going to traverse the array just exactly once. So let's run it and check. Yeah, so our answer matches with the expected answer. So let's submit and see if our answer should be in the top 100% itself. So let's check. Yeah, we are in top 100%. Our answer, our runtime beats 100% of Java solutions. So I'm going to do this every day, and every day when they upload a set of question, upload one programming question, I'll solve it and upload it on my channel. So if you want to get notified whenever I uh, solve this problem, uh, click on subscribe and click on that bell icon to get notified whenever a solution has been uploaded. Thank you.